Sanibonani, Dumelani, Abusheni, Molweni. Greetings to you all. Today we'll be doing statistics. We'll be discussing statistics from grade 11. We will be discussing the measures of central tendency, the 5-number summary, the measures of dispersion, and the calculation of the mean, and also the calculation of the quartiles. So let us start. We'll start with the measures of the central tendency. With the measures of the central tendency, we've got the mode, median, and the mean. So what is the mode? It is the most common value in the data set. Okay. And what is the median? The median is the middle value in an ordered data set. Okay, in an ordered data set. And the mean is the average of the data set. Okay, now we also have the 5-number summary. Now with the 5-number summary, we'll have the minimum value in the set. This is the lowest value in a data set. The lower quartile, Q1, the median of the lower half of an ordered data set. So before we can start taking out the minimum, the lower quartiles, and the medians, we have to first arrange the data in an ascending order. So the median is the middle value in an ordered data set. The upper quartile, Q3, the median of the upper half of an ordered data set. The maximum value in the set, the highest value in a data set. Okay, so the 5-number summary is represented visually, the 5-number summary is represented visually on a box and a whisker diagram. Okay, we'll also do the box and a whisker diagram to represent the 5-number summary. So we also have the measures of dispersion. With the measures of dispersion, we've got the range and the interquartile range. So the range is the difference between the largest value and the smallest value in the data set. That will be our range. Okay, so the range will equal to largest value minus the smallest value, like that. Okay, the interquartile range, IQR, this is the difference between the upper and the lower quartiles. Interquartile range is equal to Q3 minus Q1. So we will be using this to calculate the interquartile range. Okay. Calculation of the mean. How do we calculate the mean? Okay, the mean is the most commonly used measure of central tendency. It is commonly known as the average. The mean is the sum of the data values in the data set divided by what? Divided by the number of elements in the data set. Okay, so the mean can be represented by x bar. Okay, this x and that bar. So this will represent what? The mean. Equal to the sum of the values in the data set. This indicates what? This indicates the sum of the values in the data set. This n is the number of elements in the data set. So how can we calculate the quartiles, the upper quartile and the lower quartiles? So we can calculate with what we call the upper quartile and the lower quartile using these formulas. Okay, for the lower quartile, we'll say Q, which is Q1, is gonna be 1/4 n plus 1. So this n will be the number of what? The number of elements in the data set. So we just add 1 there. For the median, I'm going to say it's 1/2 n plus 1. Okay, that is for the median. And then we have the upper quartile. For upper quartile, Q3 This is going to equal to 3 over 4 n plus 1. Also, what you should note about this what called equation, these equations give what? They give the position of the quartiles in the data set. They do not give the actual value of the lower quartile, median, and the upper quartile. But what do? They give you the position of those quartiles in the data set. Okay, so let us do some examples to find all these things we just discussed. Now we are going to do example 1. Okay, so for example 1, we have odd number of what? Of data set. Okay, what do we have? Sisayama, a driver of Pizza Korea motorcycle, recorded the distance he traveled in kilometers on 15 trips. The data is given below. Okay, now we said this is the odd number of data set. Now let us calculate the elements that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so it means our n in this case is going to be equal to 70. Okay, now the first question is determine the mode. Okay, determine the mode. Before we can even attempt to answer this question, we'll have to arrange this data in an ascending order. Okay, hence the data must be rearranged in an ascending order. So we're going to have 10, 13, 13, 14, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 29, 30, 32. Okay, so for 1.1, I have what? An ordered data set. This is an ordered data set. Okay, determine the mode. Okay, so our mode, what is the mode? The mode common value in a data set. Okay, which value is common in the data set is what? It is 13, so it appears twice. Okay, so our mode here is going to be 13. That will be our answer for 1.1. Now let us do 1.2. What is the median for the above mentioned data? Okay, we see median is what? The median is the middle value in an ordered data set. This is an ordered data set. We don't check this one. We check this one in ordered data set. Okay, the middle value. Okay, so you can simply count what to call from this data set that we have, and you look for the middle value, or you can use the equations of the what we call of the quartiles to find what? To find the median. Okay, now for 1.2 we can just count from here and say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so that will be 2, 4, 6, 8, 10, 12, 14, 16. It means this value here 21 is going to be the middle value. Okay, so this one is going to be what? Is going to be the upper half. Here we're going to have what? Here we are going to have the upper half. Okay, this is going to be our upper half, and this one here, this data set is going to be what? Is going to be our lower half. Our lower half. Okay, so the median in this case is going to be equal to 21. Okay, median equal to what? Equal to 21. Okay, now let us check using what? Using these formulas to find what? To find the median Q2. Okay. With that, let us say it's all. Okay. Now, for us to find Q2, we mustn't forget that this formula only gives us what? The position of the median. So that will be 1 over 2 into n plus 1. Okay, so this is going to be 1 over 2. The number of elements in this data set is 17, so this is going to be 17 plus 1. Okay, so this is going to be let me punch all this. 17 plus 1. Okay, this is in scientific form. I'm resetting my calculator. That will be 1 over 2. 17 plus 1. The answer here is 9. Okay, so the answer is 9. This answer does not give us what? the median, but this answer here, what does it do? It gives us what? The position of the median. So our median is going to be position number 9. That will be 1 2 3 4 5 6 7 8 9. That will be what? That will be 21, which is the median is equal to what? Equal to 21. Just like that. Okay, good. Now what will be the next question? The next question is write down the upper and the lower quartiles. Okay, so we know that Q1 forward Q1, which is the lower quartile. Now the lower quartile is the median of what? Is the median of the lower half. Is the median of the lower half. So here we've got what? We've got the lower half. How many elements do we have in the lower half? We've got 1 2 3 4 5 6 7 8. Okay, so here we've got an even number in the lower half. So how are we going to get the median? So that value, it will be between the the fourth and fifth values. That will be how do we get that? So we're going to say we're going to add the two values and divide by 2. Okay, so in this case, this is going to be the lower quartile is going to be equal to that will be 14 plus 17 divide by what? 14 plus 17 divide by 2. So this is going to be our lower quartile. Okay, say 14 plus 17, that will be 15,5. Okay, 1 2 3 4, 1 2 3 4. Yes, these ones we add these two. So our lower quartile is going to be 15,5. We have it there. 15,5 is between those two. Okay, so the same will happen for what? The same will happen for no. We are still on the same question for the upper quartile. Okay, now for the upper quartile, we are going to have what to call the upper quartile is the median of the upper half. Okay, so we've got what? We've got 8 elements in the upper half. So we are going to add these two, the fourth and the fifth what to call numbers in the upper half. So that will be 26 plus 27 divide by 2. So our answer there, we're going to have 26 plus 27 divided by 2. We're going to have 26.5. So 26.5 is going to be here. 26.5 is going to be our 26.5 is going to be our upper quartile. Okay, so we could have used what to call the formulas to determine the position of the lower quartile and the position of the upper quartile. Okay, so we could have done this in this form. We're saying, and we could have said this is going to be Q1 is equal to 1 over 4 the number of elements in the data set, that will be 17 plus 1. Okay, from here, okay, and then we were going to get 1 over 4, 17 plus 1. We get 9,2, which is 4,5. If we have it like this, 4,5, you don't round it up. So this shows that what to call the lower quartile is between position number 4 and position number 5, which is that one. That is 1, 2, 3, 4, 4,5. It is there. It is in between. But once we get your value to be 4,8 or 4,9, you can do what? You can round it up, and that will be position number 5. Or you get what to call, if you get 4,1 or 4,2, you can always round down. Okay, and then that will be your position 4. But if you have it as 4,5, just know that what to call the median or the upper quartile or the lower quartile, if it's 0.5, it is in between the two values. Okay, so the position will be 4,5. That will be the position of what? The position of the what to call of the Q1 of the lower quartile. Now the position of the upper quartile, Q4, that will be what? 3 over 4 into 17 plus 1. What do we get there? That will be what? 13.5. If it's 13.5, it means it is between position number 13 and position number 14. Okay, now let us count what to call in our data set the position of the upper quartile. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13.5. Yes, that will be the position of what? The position of the upper quartile. So if it is in between, what do? You know, you just add the 2 and you divide by 2, and then we are going to get what? We are going to get the value of what? Of the upper quartile. Now let us now move to the next question, which is 1.4. Determine the mean kilometers traveled by Sisayama. Okay, now with the mean, that is 1.4. Now 1.4, we know that the mean is represented by what? By x bar. That will be what? The sum of the elements divided by the number of elements in the data set. We're going to have, which is equal to, we're going to have this, that will be 10 plus 13 plus 13 plus 14 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24, let's say plus I am now here, plus 23 plus 24 plus 23 plus 24 plus 26 plus 24 plus 26 plus plus 27 plus 29 plus 30 plus 32. Okay, all of these divided by what? Divided by n, and we know that it is equal to 17 divided by 17. So we are going to have, if you add all these, 10 plus 13 plus 13 plus 14 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus 26 plus 27 plus 29 plus 30 plus 32. We have 350, 358. 358 divided by what? Divided by 70. So the answer divided by 70. So our mean is going to be 21, we normally round off to 2 decimal places, that will be 21,006. So also the mean is also known as what? It's also known as the average. So once they ask you to calculate the average, you just calculate what? You just calculate the mean. Okay, good. Now the next question. Now write down the 5 number summary. Write down the 5 number summary. Now for 1.5, and then we come to see 1.5. We have to write the minimum value, lower quartile, the median, the upper quartile, and the maximum value. Okay, let us see the minimum value. Okay, so the minimum value from our data set is what? Is 10. So we're going to say here we've got 1, we have 10, and the lower quartile we got how much? 15,5. That will be 15,5. Our median is equal to 20, 21. We have 21. The upper quartile, our upper quartile, we got 26,5. Our maximum value is 32 there, because this is an ordered set. Going to have 32. Okay, so this is going to be our five number summary. Now we are going to make use of the 5 number summary of this information on the 5 number summary to draw the box and the whisker. So for us to draw the box and the whisker, we'll need a scale. So we're going to make use of a ruler to draw what? To have a scale. Okay, to draw a scale, to have scale. Okay, so now that will be what? That will be, we know that our lowest value is 10, so we are going to start at 10. So that will be what? That will be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, 32 is our maximum. It's our maximum value there. It's our maximum, and then we have our maximum value as 32. Yeah. And then I'm going to have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 30, 32. Okay, good. Now, what is the value of the minimum? The minimum value there is 10. So straight there, we're going to have what? We're going to have a stick like this. Okay, and then the maximum value is 32 there on 32, and then on 32, making use of a ruler, I'm also going to have something like this. Okay, good. Now, what is the value of the lower quartile? 15.5. 15.5 is between 15 and 16. Okay, so I'm going to make use of a ruler as well and have a line like this, and then the median is 21. I'm at 21. I will have something like this at 21, and then at the upper quartile is 26.5. 26.5 is between 26 and 27. I'm also going to have a line like this. Now, what I'm going to do, I'm going to close these triangles like this to form what? To form a box, just like this. And I'm going to have sticks like this. This is going to be a stick or an arm, and making another arm on the other side. So this is going to be what? This is going to be the minimum. This is going to represent the minimum value, and this one is Q1. This one is Q2, which is the median. This one is going to be Q3, the upper quartile, and this one will be the maximum value. The maximum value there. That's how you plot the box and the whisker to represent what? To represent the five number summary. Okay, now let us move to do the example 2. The example 2, that will be what? That will be example 2 for even number data set. Okay, for the even number data set. So for the even number data set, let us now check our data set. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is an even number. Okay, so what do we have? The maximum daily temperature for Pretoria for the first 10 days in September are recorded in the following table. Okay, determine what? Determine the mode. Before we can determine the mode, we will have to do what? We will have to rearrange this data set in an ascending order. Okay, so the lowest value here, the first value here, the first value 1, that will be 17, and then the second one will be 18, and then we're looking looking for 19, 19 is not there. We are looking for 20, 20 is there. And we're looking for 21, 21, 21 is not there. We're looking for 22, 22 is there. 1, 1, 2, 3, 4, 23, 23, 4, 5. We're looking for 23, another 23, 23 is not there. 24, 5, 6, 6. 24, 25, 6, 7, 7, 7, 8, 25, 26, no, 26, 27, 8, 9, 9, and then this is 10. Okay, so the first one will be what? The first one is going to be 17. Okay, so we are going to have 17. The second one is 18. The third one is 20. Let's do this. 20. The fourth one is 22, and then the fifth is 23. 23. The fifth is 23. The sixth is 24. 24. The seventh is 25. It's 25. And we also have the 8th as 25. And then we are going to have the 9th as what? As 27 and 28. Let me have my data like that. Okay, determine the mode. 1.1. We know that the mode is the most common value in the data set. So the most common value in the data set is 25. So our mode is going to be 25. What is the median of the above mentioned data? Okay, going to have 1.1.2. Okay, let us say we're to use what? We're to use the equation for the median. Okay, so for median, don't forget here we just get what? We just get the position of what? The position of the median in this data set by using this formula. Okay, so that will be, what is n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we know that n is equal to 10. So that will be what? That will be 1 over 2, 10 plus 1. So by making use of our calculator, 1 over 2, 10 plus 1, what do we have? 5.5. Okay, now 5.5, it is the what? It is the position of what? The position of the median in the data set. Okay, now the median will be between 1, 2, 3, 4, 5, between the fifth position and the sixth position. Okay, so how do we get the median? If that is the case, we're going to add the two. We're going to add the two values and divide by 2. So our median is going to be equal to 1, 2, 3, 4, 5, and then that will be 23 plus 24 divide by 2. So the median is going to be equal to 23 That will be 23.5. This is the value of the median. So we have what? 1 2 3 4 5. We have 23.5 there. 23.5 there as our median. Okay, so this set, this one, including that 23, that will be what? That will be our lower half. And then this one, including that 24, that will be our upper half. That will be our upper half. So now, what is the next question? The next question now is write down the upper and the lower quartiles. Okay, 1.1.3. Now this one is going to be easy for us because we have what? We have the odd data set, odd number of data set. We have 1 2 3 4 5. Okay, so we know that the lower quartile is the median of the lower half. So the median of the lower half, that will be what? That will be 20. So the lower quartile is going to be equal to 20. Okay, and the upper quartile is going to be equal to, just count here, 1 2 3. This one is the middle one. So the upper quartile is going to be 20 25. Okay, we can also make use of what? We can also make use of the equations to determine the position of the lower quartile. Now, using the equations, we know that Q1 is going to be 1 over 4 n plus 1. We have it there, 1 over 4 n plus 1. So what is n? And we know that is 10. This is going to be 10 plus 1. 10 plus 1. And then what will be the answer there? 1 over 4, 10 plus 1. The answer is what? Is 2,75. Okay, so remember I said once it is 2,7, you just round it up, that is 2,75, which is approximately 3. This is next to 3. So that is position number 3. Position number 3, 1 2 3. What do we have? We have 20 there. That is the value of the lower quartile. Coming to this, using the equation for the upper quartile, Q3, this is going to be 3 over 4 into 10 plus 1. And then what do we get there? We get 8,25. So if you get 8,25, we round it down. So we're going to have what here? We're going to have 8. Also on the 8th position, what do we have? We'll have the upper quartile. So let us count. 1 2 3 4 5 6 7 8. This one is going to be our upper quartile, which is this 25. So that's how useful these equations can be. Now let us move to the next question. Here we are asked to determine what to call the mean. No, this is not supposed to be the mean for Sisayama. This should be the mean for what? For the daily temperatures of Pretoria. The mean temperature for what? For daily temperatures. For daily temperatures. Okay, good. Now for the mean, that is 1.1.4. For mean, the sum of x over n, so we're going to say that will be 17 plus 18 plus 20 plus 22 plus 23 plus 24 plus 25 plus 25 plus 27 plus 28, all divided by 10. This is going to be 17 plus 18 plus 20 plus 22 plus 23 plus 24 plus 25 plus 25 plus 27 plus 28. Let me get the sum before. This is 229 divided by 10. 29 divided by 10. The answer will be 22,9. So this is going to be the average. The average temperature. Don't forget also the mean is also the average temperatures. Okay, and then the next question is write down the five number summary. So with the 5 number summary, 1.5, we're gonna have the minimum value, lower quartile, median, upper quartile, maximum value. Okay, so the minimum value here, we've got 17. The maximum value there, we have 28. That will be 28, and then we have 23.5 as our median, and then we have lower quartile is equal to 20, and then the upper quartile is equal to 25, okay. So now on the next question, we are asked to draw a box and a whisker diagram for the data. We know that for us to draw the box and the whisker, we need to use the 5 number summary. So we're going to have what? Let us now see, we started at 16. Maybe we started at 16. That will be 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay. Now, let us see now. I'm starting at 15. After 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 30, 32. Okay, so now we start with the minimum value. The minimum value in this case is 17. So we are going to have 17 there. The next one is the lower quartile. The lower quartile is equal to 20. We come to 20 there. So something like that. The median is 23.5. 23.5 is between 23 and 24 there. And then we have something like this. And then we're gonna have upper quartile, which is equal to 25. And then we're going to have 25 like that. And then we are going to have 28 there. We have 28 as our maximum value. So what I'm going to do, we just make a box with these three like this, and then we just create an arm there, and then an arm there. Okay, good. I would like to add two questions here. One question is 1.7, like calculate the range and the interquartile range. Calculate the range and the interquartile range. 1.7. So this one was 1.1.6. So for 1.7, if we were to calculate the range, we know that the range will be equal to the difference between the largest value and the smallest value, which is the maximum value and the minimum value. So it's gonna be maximum value minus the minimum value. Okay, so that will be what? That will be 28 minus 17. Okay, so our range will be 28 minus 17, 11. That will be our range. So for the interquartile range, the interquartile range is equal to Q3 minus what? Minus Q1. The upper quartile minus the lower quartile. So the upper quartile is 25, the lower quartile is 20. So we're going to say 25 minus 20. Then the answer is what? The answer is 5. So this is how we will determine the range and the interquartile range. So that will be it for this lesson. I thank you.